October 17th, 2024 marks the 75th year of the commencement of the Snowy Mountains Hydro Scheme. I'm Paul Michael Angus, a mechanical and civil engineer in Australia's water sector. Come with me as I explore the timeline, the components, and the challenges faced throughout its construction, as well as celebrate the amazing elements of this engineering wonder. Hopefully, by now, these episodes have provided some insight into the design and building of the Snowy Scheme. But given the order in which everything was built over the 2.5 decades, I'd not be surprised if you're still looking at the map of the scheme and struggling to understand where and how every bit of water enters and leaves the systems. And so due to this, I've created these last 2 episodes, which will look at the Snowy Murray and the Snowy Timit development flow paths, and take you on the journey which the water itself would see after falling onto the Kosciuszko National Park high plains as rain or snow, and then melting and entering streams and tributaries which are the source of the diverted rivers. This episode focuses on the first development finished in full, the Snowy Murray development, in the southern region of the Snowy Scheme. But first, you're probably wondering, where have I got all my information from? Aren't you? Well, outside of your typical Google search and review of Wikipedia articles, my initial interest broadened somewhat into reading old books from the 1960s and 1970s, as well as newer editions which have been converted to metric units. Likewise, via the National Library of Australia's Trove search engine, I was able to access annual reports from 1950 onwards, many penned by Hudson and his team, and speaking to the issues they encountered each year. I also got into a bit of a bad habit on eBay, Gumtree, and Marketplace, buying a bundle of old documentation which showed the status of works at various points through its construction. Unsurprisingly though, Snowy over the years have released several videos as part of their public relations initiatives, although many of these speak to more the intent and benefits of the scheme and the cultural diversity it provided to our society, rather than the planning and engineering challenges. You'll see, however, I've borrowed some of this archive footage throughout these episodes. This episode, as mentioned, covers the flow path of water through the Snowy Murray development, which draws its flows from the Snowy River catchment and provides the portion of the scheme's water that the state of Victoria uses for irrigation. Of the 15 large dams built, 6 of these, excluding Eucumbene, make up the better part of the Snowy Murray development, the remainder residing in the Snowy Timit development to the north. Water within this development falls an elevation of roughly 1,200 metres between Guthaga Dam and Cankoban Pondage, making its way through 3 hydropower stations and also potentially 1 pumping station along its path. Along the way also, due to numerous aqueducts and intermediate intakes, separate water sources also feed into the Snowy Murray development, increasing yield for both energy production and irrigation. To travel along the water's journey, we must now start from the top, Guthaga. Guthaga Dam impounds the upper Snowy River, where it is fed from Mount Kosciuszko's slopes and along with some approximate 28 kilometres of aqueducts downstream of the dam wall on both sides of the valley, collecting additional runoff from numerous tributary streams. From the dam itself, the most likely path of water is through the pressure tunnel towards the Guthaga Power Station. However, some flow seasonally makes it over the dam wall and back to its natural course along the Snowy River upstream of the Guthaga Power Station. Water will make its way through the Horseshoe Pressure Tunnel towards the surge tank and valve house, before then falling down the mountainside via the numerous pressured pipelines which enter the hydro facility. At this point, water will enter the 2 30-megawatt turbines and then be discharged back into the Snowy River immediately downstream of the Guthaga Power Station, some 7-ish kilometres upstream of Island Bend, where it will once again be impounded. After entering the Island Bend pondage, water will almost always be diverted towards Gihai or Yukonbean reservoirs via the outlet structure, connecting to the deep Transmountain tunnels below. However, if this weren't to occur, mainly due to very high seasonal flows, water would then flow over the dam wall via the spillway gates and continue along the upper Snowy River until it arrives at Lake Jindabyne. Now, once in Lake Jindabyne, the most probable path from here won't be to rejoin the lower Snowy River, sadly, given that whilst there are riparian and environmental releases downstream of the dam, it's actually more likely you'll shortly rejoin the water which was sent to Gihai Reservoir via the Jindabyne pumping station. From the Jindabyne pumping station, the water stored in the reservoir will be pumped back up into the Snowy Murray development via a pair of pumps in series. Typically, this will only happen during low energy demand periods, when surplus energy is cheaper. Flows will rejoin the Transmountain Tunnel heading towards Gihai Reservoir via a steel pressure pipeline heading towards a surge tank and travel along a largely unlined rock pressure tunnel back towards the Island Bend Transmountain Tunnel junction. For this to occur, the other control structures must be closed to prevent excessive pressure on these pump sets. So we're now at a key junction point of this part of the scheme, where water stored in Yukonbean or Jindabyne reservoirs, as well as general runoff from Island Bend, can be diverted towards Gihai Reservoir, entering by the large and complex inlet-outlet structure. Once water enters the Gihai Reservoir, it will also join other flows diverted via the Middle and Gihai aqueducts, which draw flows off nearby tributary streams downstream of the dam wall itself. From Gihai's outlet structure, water will then flow towards Murray 1 power station and additionally join flows introduced from the Burke's Gorge and Cascade Creek aqueducts via an intermediate intake shaft. From this point onwards, though, water will now enter the pressure pipelines immediately downstream of the Murray 1 power station surge shaft, which lies within the mountain range. Water from this point will fall some 400 approximate metres before entering one of the 10 95 megawatt turbine units within Murray 1, then leaving the power station outlet and joining the Cancoban Back Creek, impounded at this point in the river by the Murray 2 dam and its outlet structure. Now, the Murray 2 pondage isn't very large at all and serves mainly to be a buffer between the two power stations, which normally would run at similar flow rate capacities due to this small storage. Once within the storage, however, the next stop along the way will be the Murray 2 dam outlet towards the final pressure tunnel within this section of the Snowy scheme. After flowing through this pressure tunnel, of which 100% of this is concrete lined, water will then flow by the last surge shaft and into two pressure pipelines leading towards Murray 2 via an overland route. Water within these two pressure pipes will fall roughly 250 metres into Murray 2 power station, the last in the Snowy Murray development. After entering and leaving one of its four 137.5 megawatt turbines, the flows will be impounded within Cancoban Pondage in preparation for irrigation releases to the Murray River. When a suitable time comes for the water to be released from Cancoban, the next stop along its journey to the mouth of the Murray River will be the Hume Dam and its reservoir, which was raised during the Snowy's original construction. After Hume Dam, these waters would continue to flow along the Murray towards South Australia, with many more weirs and barrages in use, regulating the flow of this river separate to that of the Snowy scheme. And so, with that, you've now followed the full path of water as it falls either as rain or snow onto the high plains of Mount Kosciuszko and then into the Snowy River. Along with this main diversion, you've also observed where other tributary streams north of the Great Dividing Range are harvested and fed into the Snowy Murray development, further expanding its generating potential and irrigation yield. This is, however, only one half of the overall Snowy scheme, and eventually both developments and their diverted flows will once again join at the Murray River before it reaches Mildura. The next and final episode in this series will follow this second half of the overall flow path through the Snowy scheme via the Snowy Tumut development. Thanks again for watching, and I hope you've been enjoying these episodes celebrating the 75th anniversary of the commencement of the Snowy Hydro scheme.